S. Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello friends, as we have done in the previous video about the operation amplifier, which is used as a adder, which is used as a summer, and which is inverting and a non-inverting mode. So in this video we'll proceed further with a different kind of opamp and their uses.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box.
So welcome to the Ascent Academy, and my name is Kanhaiya Jha. So today we will going to cover some other parameters of the operation amplifier. The first thing that we cover is integrator, that how we are using opamp as an integrator in this. So we can see here that we have made a opamp, as we have learned in the previous videos, that how, and we have designed the basic idea of the opamp and the basic circuit of the opamp. So depending upon that, we make a basic circuit of opamp here with a basic circuit. We can see that the input Z1 and Z2 are connected here. Z1 here to Z2. V0 by Vi is equal to minus of Z1 by Z2. So this is the inverting configuration. Inverting configuration, we have a general impedance. General impedance as a name impedance, total effective resistance of the particular circuit. So this is used as an integrated circuit. Here is an inverting integrator. Here we can see that non-inverting integrator, there is an inverting integrator here. So again we can see that how the resistor is connected, how the capacitor is connected in the particular inverting integrator when the op-amp is used as an integrator. So we are calculating the output VO is equal to I by CR, integration of VF, the total integration of this. So when we see this particular integration, it means that the entire input is integrated, and from the entire input integrated, you are getting the particular output. So it is a input integrator. Frequency response is 1 by CR that we will generally calculate. So this is V0 by Vi, and then 1 by CR, we can see that how the slope generally moves here. So this is the particular graphical representation between this particular value of CR and the V0 by Vi. Then we have the operation amplifier as a differentiator. We have discussed till yet as a summer, as an adder, as a integrator. Now we will discuss the operation amplifier as the differentiator, that how the operation amplifier can be used as a differentiator, how we can make the particular calculation. Here we can see the operation amplifier with one leg is grounded. We can see here that one particular leg is grounded, and then we can see the capacitor is connected here and the one particular resistor is connected here, and then we have to calculate. So IT is equal to C dV by dt, V0 T is equal to 1 minus CR dV1 by dt, and V0 by Vi is equal to minus of CR. So we can see here that how it can be used as a differentiator. We are using a capacitor and we are using a particular resistor with the one particular grounded. So if we focus, we can make it like this. So this is can be grounded, and this can be connected to the one value of the capacitor that we want to use, and then a resistor can be used for this. As we can see in the particular circuit also, that how this particular circuit is made. So here we can see. So here we can see that this is the capacitor, there is a resistor, and from here we are calculating the variation in the particular circuit with respect to this, and whatever the changes in the voltage, we say dV by dt or dV1 by dt, or this is CR dV1 by dt. So we are able to calculate V0 by Vi in this, okay, very particularly, that we are using all the particular sources and then we are making the particular calculation. So all these particular sources can be generally used, okay, and then we make the calculation. Here you can see the frequency response. Here we can see how it can be used. We are calculating the rate of change. As we have discussed in the previous video, what is a differentiator. So differentiator is basically the op-amp as a differentiator. It will calculate the amplification value even when we have a changes in the output, when we have a changes in the particular concerned output, and during those particular changes, this particular op-amp can be used to make the particular calculation. It can be used to make the particular changes in the particular value, and then we can make the particular changes. Here we can see all these values and all the changes in this particular values. So this is used as a differentiator. In the integrator, we have seen that how the particular the different values of the input were integrated together so that we can get the particular value of the output. The output that we have calculated the particular values of the input, and then we were calculating the particular value of the output. So integrator also, we integrate the values, and the output we are differentiating the particular value, and whatever the rate of change that we have in the input, according to that we can calculate the output particular thing. So the reason we are using the capacitor, it is a capacitive circuit, here is a resistor, and then we are using this. Then we have this particular again coming back to this integrator. Integrator is I focus again integrator, again you can see this and this. When this Z1 and Z2 will be integrated in the output, we will get the output. We can see the circuit of this here, that how the V output is basically the integral value of the V here, and we calculate it. So here we can see that the C is used here in the differentiator, the capacitor was used here, and the resistors were used here. So there is a difference, that when in one case we want to calculate the integrated value, in one case we calculate the differentiated value. The differentiated value will be basically that whenever there is a rate of change occurring in the input. So depending upon the rate of change which is occurring in the particular input, and depending upon those values, we can calculate the value of the particular output. So depending upon the values of the input, we generally calculate the values of the particular output in this case. So the input and the output both can be calculated very easily. So the variation in the input and the variation in the output can be calculated by this particular calculation. So either here we need to understand one thing, that how we are making changes in the input. How, if you make a change in the input, it will become inverting or it will become a non-inverting. It will make a change in the input, it will become an adder. It will make a change in the input, it will make a, it will make a we can calculate this as a summer. If we can use as a different operational amplifier together, making variation in the particular input, again we can get a combined output. Combined output will generally include all the variation in the particular input, and then we can make the calculation. Then we can use an integrator where the output will be the integrated factor of all the particular inputs. All the inputs that we calculate, the output will be the integrated factor of the particular input. And then most important, that when we calculate the differentiator, the differentiator, whatever the rate of change which is occurring here, which can be calculated. So circuit is very simple, that how the two inputs are integrated together, how we are calculating the value of the voltages, how the ratio of the V0 by Vi is generally calculated, how we are making this calculations, okay, how this particular the inverting thing which can be calculated, and then we can calculate the integration factor. So we can use this as an adder, we can use this as an integrator, we can use this as a differentiator also. So as an integrator, it will calculate the, basically the student asks that what is the difference between adder and an integrator. Adder will generally add the input, and the integrator will integrate all the particular inputs including their rate of changes. Where we are having the rate of changes in the input and we want to calculate the output according to the changes that occurred in the input, that we can calculate in the differentiator. So the concept of the adder, summer, and the integrator and the differentiator must be very clear to us, that how they are calculated, how we calculate it from the input, how we proceed to the particular output. Again, coming back to this, what is the purpose of using the resistor and the capacitor circuit? Because we can see that in the adder and in the particular differentiator and the particular integrator, the position of the particular resistor and the position of the particular capacitor, they are different. We are using differently in the integrator and we are using differently in the differentiator. So both the connectivities are generally different, because in one case we need a total effect, and in another case whatever the changes occurring, we calculate the output according to that. So that is why in one case we integrate the particular value, and in another case we are differentiating the value. Whatever the value of the voltages that we have, we are differentiating it. So here we are integrating it, taking the 1 by CR, and here we need to integrate, it, differentiate it. So we can see that here the capacitor and the resistor are used, and again we are differentiating CV1 by dt, then CR dV1 by dt, and then we are calculating this particular value. So in one case we are using this as a integrator, where the integrating with the different values, and in one case we are using it as a particular differentiator. We are differentiating this, we are calculating this as a different values, and then we are making the calculation. So in this particular thing we will learn that how from the adder we come to the integrator, from the integrator how we calculate the differentiator. Either we are summing up the inputs, or we are making changes in the input, or we want to integrate from the one particular value to another particular value. So these all operations can we do in the operational amplifier. Now we will take a small break, and after the break we proceed further.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
So welcome back. So till yet what we have discussed in the videos was how the operation amplifier can be used as a differentiator, how it can be used as a integrator. From the simple operation amplifier we design the circuits according to the uses, that how it is basically used as a basically the summer, the integrator, the differentiator, and all that. So again, coming back to the concept that depending upon the use we design it. Okay, so again, if we need a differentiator, we design a differentiator operation amplifier. If we need integrator, we design the integrator amplifier. So depending upon how the uses variation, on that particular variation we will make the calculation, will make use this particular operation amplifier for the different particular values, and then we'll study it. So now we'll focus about the concept of the integrator, and the concept of the differentiator is very much clear. So we'll proceed further, and we come to the concept here. The concept is basically this is a graph of the differentiator what we have done. Then the particular simulation of circuit. Stimulation is a very important concept in this. Stimulation is that how we analyze the circuit. If you know the stimulation, and if you are in the further study, and if you want to develop our output or develop our study from one particular part to the software part, then also we can do it. Stimulation, see, this is how the opamp is generally used. This is one and this is another one, A1 and A2, and this is how the resistors are connected to each other, where we calculate the particular input as V1 by R1. So V1 by R1, when we use the particular rules, it will be C5, C2, R1, R3, R5, and IR2. So this is the particular value that we will get. We are doing the simulation. You can see that how the resistors are generally connected to each other, and the capacitor is connected. How we are connecting the two particular operational amplifier together, and when in the particular connectivity of the two particular amplifier, what and how much we are getting the particular output. So this is very important, that we are getting the collective output, whatever the particular variation that we do, but here we are getting the particular collective output from the one particular source to another particular source. We are getting the collective output in this. So we can study here. Now here we can see the inductance simulation circuit, that how the induction, in this circuit we can see that how stimulation done. Now we'll do the particular formula. here. So we can see here that here we can see V1 minus V1 R2, then the capacitor 4 R5 R3, okay, then V1 R2, then C4 R5 R3 R1, okay. So how we are calculating the particular variation? We start it from the input V1 by I1, then we come to this particular calculations. So if you, I have numbered them all, that how to make the calculations here. So basically this is the 1, this is 2, this is 3, 4, 5, then 6 and then 7. As we have discussed, if you remember in the video number 1 of the operational amplifier, 6 and 7 will be calculated with the output. You can see here clearly 6 and 7, that how 6 and 7 are generally calculated as output. Then we have 8, 9, 10, we can vary, then 11, you can see here, start from here, 11, and then we can calculate the 11, 12, 13, then 11, you can see the 12, 13, 14, 15, and finally come to the 16, then 17 and 18. So 1 and 2, we can see that how they are used for the input, then how which leg is generally used for the output, and how we can proceed with the other legs, and we are getting the final leg. So this particular circuit will enable you to learn in a better way, where we can see all the numbers. You can practice it using the numbers. You can practice it using the given set of the input. You can practice this using the given set of the output. So numbering enables us to look like this. So 1, 2, 3, 4, and then you can proceed further with 5 and 7, 6 and 7. We can see the input and the output. Then you can see it for the upper one, all the calculation, and you can see till 18. So all these particular legs you can stimulate and calculate by yourself also, that what happens in the leg 1, what happens in the leg 2, how the input is given between the leg 1 and the leg 2, how the output is calculated with the different particular legs, and how we are calculating the different variation to make the particular calculations and all. So this is basically very important when we are doing this. So all these variations can be calculated. Then we have resonator, that we are using the operation amplifier as a resonance circuit. So we can see that we are using the inductive circuit, we are using the capacitive circuit, and then we are using this. So this is the LCR circuit basically, that L, C, and this is R. So we are using the capacitor and we are calculating resonance. So LCR circuit is basically used because in the pure resistive circuit we know that the voltage and the current are in the same phase. In the inductive circuit, the current lags the voltage. In the similarly capacitive voltage, the current leads the voltage. So we are using all these three to make the LCR circuit, and we are using it with the operational amplifier. We are basically using this particular circuit to check the particular operational amplifier as a resonant frequency. So it is called as a resonator. Then we have the circuit analysis of the resonator, that how the particular circuit has been made. So we can see that we are using the particular opamp as we have seen in the previous circuit also, which is connected to the R1, R2, R3 and the capacitor 4. How this particular circuit is connected with the inductor, and then how it is connected with the values. We can see that operation amplifier RC resonator. This is obtained by replacing the inductor L in the LCR circuit resonator or the stimulated inductance realized by the continuous circuit. So this is how the variation in the particular circuit can be calculated, how we calculate the variations in the circuit, how all the variations can be calculated. This entire variation we can see. This is the amplifier 1, this is the amplifier 2, and then we make the connectivity, and then we can make the particular calculations. So these all calculations can be done here. Then we have opamp RC resonator, we have already discussed this one. And then we have to study again that what happens and why we are using the LCR circuit in the circuit. Why we need to make a circuit which can work on the resonator as a natural frequency. So here we study that how the operational amplifier, when we make changes in the input, how it becomes an adder, how we are using the different values, how it becomes summer, how we sum up the different values, how it can be used as an integrator, where for the particular given inputs, we are integrating the particular values and then we are calculating. How, not even legs, but yes, how we are going to use the different operation amplifiers which are connected to each other and they are giving a collective output. How we are using it in a differentiator, that we are at a different value of the rate of change. These particular operation amplifiers are generally used. Whatever the changes are there, the differential amplifier are generally used for the calculations and all. And after that, we have studied that from the integrator, we are calculating with the RC circuits also. We are making the LCR circuit with a particular operation amplifier, and we are calculating the impedance, and we are calculating in the output also. So how the calculations are generally done. So in a very summing language, this particular thing is very important, that how stimulation is generally calculated in this circuit, that how we calculate the stimulations in this particular circuit, how the legs, as we have seen this particular circuit as a combination, then we have put the number of legs in the particular circuit, then how the number of legs generally matters in this, that the variation in the number of legs and the number of legs generally varies, and then we make the particular calculation in this particular leg. So each leg has basically all the calculations that we generally do with this circuit. So this particular operation amplifier, either it is used as an adder, either it is used as a integrator, either it is used as a inverting mode, non-inverting mode, or it is used as a differentiator. We can see that we make the changes in the input, and depending upon the changes in the input, we can calculate it. Suppose we can see this particular figure, that it is basically, we have done this before the break, that how it is used as an adder, simply adder. We can see that in very closed circuit, that how it is used as an adder, that we generally integrated, how we integrate the particular value, and after integrating the particular value, we will calculate it, how we integrate the values in this Z1 and Z2. Then similarly way, we can see that how it is used as a particular differentiated value. We can calculate the changes, the rate of change from the input to the particular output. Then we have calculated that the stimulation will generally lead us for the calculation of the different legs, how the input is given and how the output is calculated. So in a summary way, what we have done, that we have first studied an ideal op-amp, and from that ideal op-amp, we have discussed the input and the output. Now what we have done is the changes in the ideal op-amp. The nature of change that we do in the input will get the output in the same way, and according to that, the op-amp is named. For example, when we are adding the input, becomes adder. When we are summing up the different operation amplifier with a particular given input, that becomes a summer. When we are doing the integrator, integrating the inputs, it becomes an integrator. When we are differentiating the different inputs to get a particular output, that becomes a differentiator. So by this, we study that from ideal op-amp, inverting, non-inverting, adders, then differentiator, integrator, all these kind of op-amps that you study. And in all the cases, that what variation that we do in the input, and depending upon that particular variation, that how we calculate the particular output. So the idea of the op-amp, hope more clear to you, and I hope that you have enjoyed this video. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.